Hello students, welcome to the channel of Vedant classes. Okay, so in this lecture we'll see the basic terms that are related to the spherical mirror. Okay, so we'll see all the terms that you can see it in your screen one by one. Okay, so now let's consider one spherical mirror. Okay, here we are considering the spherical mirror to be a concave mirror. Okay, so this is our spherical mirror MN, let's say. Okay, you can consider a line passing through the center of spherical mirror. The center point is called the pole, that is noted as P. Okay, the center point is called pole, that is noted as P. Now we have seen in the previous lecture that a spherical mirror is made out, it's cut out of a spherical ball. Okay, so you can consider one spherical ball like this. Okay, and the mirror is just a part of the spherical ball. So this sphere is having its own center. So this sphere is having its center, and that is called a center of curvature. Okay, so let's say it is forming a sphere, imaginary sphere like this. Okay, something like this. Then it is having its center somewhere over here, this imaginary sphere. So this point is called the center of curvature. Okay, now the distance between the center of curvature and pole, this distance from center of curvature to pole, and this distance is called radius of curvature. It is called as radius of curvature because you know the distance from the center to the outer part, and it's known as radius. Okay, so that is the reason it is called radius of curvature. Okay, now you can see the line passing through the point P and C, that imaginary line, and that imaginary line is called principal axis, and this imaginary line is called principal axis. Okay, now see, if you incident light on the surface, okay, let's say this is a concave mirror and this is its principal axis. Now if consider the parallel incident rays, okay, like this, if you consider the parallel incident rays like this, then they will converge to pass through a single point like this. Okay, they will converge to pass through a single point like this, and this point is called as focus. This point is known as focus. Okay, so you can see that in the case of concave mirror, that here we have considered the concave mirror. So in that case the focus is in front, okay, of the mirror. In the case of convex mirror, okay, if you consider the principal axis, then this parallel incident light rays will diverge. Okay, as it is a divergent mirror, so they will diverge and it will tend to pass through a point, okay, behind the mirror. So in case of convex mirror, you will get the focal point behind the mirror. Okay, so here we will have the focal point in between C and F. Okay, so this distance between F and P, this distance between F and P, this is known as focal length. This distance is called focal length, and you can see the distance of curvature from M to N. This is known as aperture. The diameter of the reflecting surface is known as aperture. Okay, so all the terminologies that you can see it in your screen. So let's clear it one by one perfectly. See, what is pole? The center of reflecting surface of spherical mirror. So center of reflecting surface of spherical mirror is called pole. What is center of curvature? The reflecting surface of spherical mirror forms a part of sphere. So reflecting surface, here it is a reflecting surface. It is formed from a part of sphere. The sphere center is called center of curvature. The sphere center is called the center of curvature. Now you can see that this pole lies on the surface of mirror. You can see it lies on the surface of mirror, but C is not a part of mirror because it is outside the mirror. Okay, now you can see that C in front, then it will be a concave mirror, and C behind, then it will be a convex mirror. Now we can see that here the sphere is forming like this, so C will be here, and for the convex mirror it will be behind the mirror, you can say, because C will be somewhere over here for the convex mirror, so it will be behind the mirror. Okay, now radius of curvature, the radius of sphere of which the reflecting surface of spherical mirror forms a part. So radius of the sphere, this is known as radius of curvature. Okay, so it is basically the distance between C and P. You can also write it distance between center of curvature and pole. It is also called as radius of curvature. Okay, now principal axis, a straight line passing through the pole and the center of curvature, a straight line that passes through the pole and C, and that is known as principal axis. Principal axis is imaginary axis. Now you can see that principal axis is normal to the mirror at its pole. You can see that here, if you are considering surface like this, then principal axis will be normal to the mirror at pole. Okay, now principal focus, this is a very important definition. Please understand this one perfectly. See, rays parallel to the principal axis, that what we have considered, this rays parallel to the principal axis, that falling on the concave mirror, okay, meet or intersect at a point, and that point is called focus, principal focus for the concave mirror. Okay, so I hope this definition is clear. So remember this technical definition for the principal focus. Now see, for the convex mirror, this definition is for the concave mirror, this definition is for the convex mirror. Okay, now see, the reflected rays appears to come from a point on the principal axis when rays parallel to the principal axis fall on a convex mirror. Now see, when rays fall on the convex mirror, then the reflected ray appears to meet. Okay, they are not actually meeting, but it appears to meet, and that point, at which point this appears to meet, that point is called the principal focus for the convex mirror. Okay, so it is always behind the mirror, just like the center of curvature. Now what is focal length? The distance between the pole and the principal focus, the distance between the pole and principal focus, and that distance is called focal length. Okay, and what is aperture? Aperture means the diameter of the reflecting surface of the mirror, and that is called as aperture. So take a screenshot of this one. It is very important to learn all this basic term to clear the chapter ahead. Okay, so please take a screenshot of this so we can move ahead. Okay, now let's see the few important notes. Okay, first of all, so first note is that when any line passes through center of curvature, that is point C. Okay, when any line passes through center of curvature, then it will be normal to the reflecting surface. So remember this important point. Okay, when any line is passing through the center of curvature, that is point C, then it will be a normal to the reflecting surface. If any surface is there, then this will be considered as normal. Normal is always taken as 90 degree to the surface. Then secondly, okay, then next we will see that here we are considering one assumption while learning this. So that important assumption is that we always consider the spherical mirrors whose aperture, okay, we are learning the spherical mirrors whose aperture is much smaller than compared to the radius of curvature. Okay, radius of curvature. So these are considered as a small apertures. Okay, so we are learning this small apertures. We are considering only this kind of situation in the entire chapter of ray optics. Okay, so in such situations we have radius of curvature twice the focal length. We don't need to prove this one, we just need to accept the result. Okay, so right now we just need to accept the result. So the R is equal to 2F. Okay, so that is the case that one should remember. Okay, so now let's see the various cases, various rules using which we can locate an image. So how many rays we need? Minimum 2 rays. So out of these 4 you can choose any two rays to locate an image. So let's see the rules one by one. Okay, so in the first case, one need to consider the parallel incident ray. Okay, parallel incident ray, that is parallel to the principal axis. Then it will pass through the focus. The parallel incident ray will pass through focus. Now you can see that when you consider the imaginary line which is passing through C, okay, so it will form an I, and here it will be R. So laws of reflection is followed in this case. Okay, now if you consider the same situation in the case of convex mirror, then one consider the parallel incident ray. Okay, then it will diverge the light ray, it will diverge. Okay, so it will apparently passing through the point, and that point is called principal focus. Here also, if you consider the imaginary line that is passing through the C, so this will be an angle of incidence, and this will be the angle of reflection. Okay, so you can see that. Now let's see the second case. Now how you can remember this case? See, we considered the parallel rays, so you can remember it like this: parallel, then focus, parallel, focus. Okay, so this is the first case. Now let's see the second case, when it is just the inverse of this one. When any light ray, it is passing through the principal focus, then it will be parallel to the principal axis. If light ray is passing through principal focus, then it will get parallel to the principal axis after reflection. Now if you consider the line passing through the center of curvature, imaginary line, so this will be your I and this will be your R. Again, the laws of reflection is followed in this case. Okay, now let's consider that that light is incident on the convex mirror like this. Okay, apparently it is passing through focus, then it will be parallel after reflection. Now again, here if you consider the line passing through the C, okay, so this will be your angle of incidence and this will be your angle of reflection. Again, the laws of reflection is followed in this case. Okay, now you can remember this case as focus, then parallel. If the light ray passing through the principal focus, then it will be parallel to the principal axis after reflection. Now let's see the third case. Now in the third case, if light ray is incident passing through the center of curvature, then it will reflect back on the same path. As it is incident normally, then it will reflect back on the same path. Okay, in this case it will be like this. Apparently, if it is passing through the center of curvature, then it will reflect back on the same path again. So this case you can remember center of curvature, then it will pass through center of curvature, or you can say it will retrace back the path. Okay, now in the fourth case, you can consider if the light is incident on the pole of the mirror by making an angle I with reference to principal axis, then it will reflect back like this, making angle R. Here I will be equal to R. Okay, and same in the case of convex mirror. If you consider the incident ray that is making I with the principal axis, then it will reflect back like this, forming angle R. Okay, so in this case, at pole you can follow the laws of reflection. Okay, so here laws of reflection aren't violated in any of the case. So take a screenshot of this important note. Okay, and that's it from this lecture. If you are having any doubts, then you can mention your doubts in the comment section. So please like, subscribe and share the channels if you are enjoying the learning in this platform, in this channel. Okay, so keep working hard, keep learning. Thanks a lot.